Hello,
Hello, Aljan.
hello, how are you?
I'm good. Your co-host now.
All right. So it is I never been co-host, but I guess it's host tools are provided, right? Extra to the interface. Hmm.
You can
Yeah,
you
exactly.
can turn on your video and
Yeah, sure. All right.
guys just give you some extra permissions.
Mm-hmm.
I'll be. I mean, there's a panel discussion, so the plan is that panelists would kind of give a position statement,
Hmm.
and then I'll just open it up so anyone can talk.
Yep.
We will. So so we're streaming right now on
Mm-hmm.
YouTube.
Mike Bennett came. If you didn't saw it.
Oh, Mike is here.
Mhm.
Hi everyone,
Hello.
I'm here.
Mike, who else is on the panel?
So we've got Corey Casanave, Max Gilmore, and Alajan Tazun, all of whom are here. I see. Welcome everyone.
There's some familiar faces. Hello.
Indeed, hi Bill.
I was going to turn on my camera, but it said that you won't let me. Oh, man.
Okay. Okay,
Still a couple of
who's on
minutes
the panel
before
again? I have Max and Corey.
Corey and Alajan.
Mm-hmm.
Okay, I think all of the panelists are now co-hosts. So Mike, I assume you want each of the panelists to give a brief position.
That's right, yes, and some will have slides and some won't. So basic position, introduction, and then I shall try and lob a few questions at them, probably let the conversation find its way, and then when things calm down a bit, we'll take audience questions as well and see how that goes. So it's pretty unstructured. I'll do some introductory notes and slides first. Corey can only make it till half past the hour, so I'll probably get him to go first on the introductions, but otherwise we haven't talked about what order we're going in, so whatever works for people. So,
Okay, so I will start the session. Welcome everyone to the Ontology Summit 2025. Today is the 9th of April 2025. And today we are having a panel discussion at the conclusion of track 3. And this will be run by Mike Bennett, and we have our panelists here. And he will take it from here. Mike?
thanks, Ken. So let me just share my screen. I need to just displace your thing. I think I can do that. Even better. So I'll do a few introductory notes. Welcome everyone to this panel. As Ken says, we're going to try and pull together some of the threads from track 3 and some of the topics we've been looking at, maybe pick up some topics that may or may not have been explicitly covered by our speakers up to now. So again, the theme of this track is how we get from reality to data. And so within the broader context of obviously the summit theme of conceptualization, analysis, and formalization. So in other words, how do we get from ontology to represent real things in the world? So we've talked a bit on previous tracks as well about truth makers. What are the things in the world that make something what it is? What does it mean to mean a particular thing based on real world stuff predicated on real things? But how do we get from that to useful applications, whether it's for data, like data integration, or any kind of semantic processing or other data intensive applications, or in more business facing things like reporting and management dashboards and things? What about AI, including large language models, digital twins, and so on? And indeed, once you decouple the data side of things from the meaning side of things, is the more you can do with data, like describing necessary shapes in data, or data quality, or provenance measures, or things like that that relate to the relationship between the data and the real things. So in other words, what are the advantages of having this separation of concern versus what are the disadvantages? And with different people working in industry, we have different perspectives on that. So I'm going to quickly show just a couple of quick slides to level set it, and then what we're going to look at from the panel is, in practical experience, what works, what doesn't work. Does the separation of concerns work? Does it help or hinder having a separate model of the concepts of real things versus data, versus doing it all together? Does it work to have foundational and top level ontologies within a client ontology development scenario, or does that hinder? What are the pros and cons? What sort of things do clients resist, or perhaps just not even want to see, but we just do them anyway? What are the different methodological approaches to that? So you remember when I introduced this track, I produced this big old slide about the different kinds of things that could be an ontology, the different kinds of model that you could call ontology, and all the way from explanatory or concept-facing ontology that represents real things in the world, through to conceptual data ontologies which reflect real things but with data types, the data surrogates and so on, versus ontologies that are just taking existing data model and putting it in a RDF or ontology format. How do you extract different application ontologies for different reasoning applications and so on? What about knowledge graphs and all these different, we often think, oh, somebody wants an ontology, here's an ontology, and try and make it one size fits all. Does that work, or do we have this separation of concerns? So that's kind of the broad background. And something we've been noodling about here, these are new slides, and I'll be interested if they work or not. We talk about the direction of instantiation. So if you think of a classic UML model, you have a model, and the role of, say, a UML class, for example, is to create a kind of cookie cutter that says, okay, this class description tells me how much data, what data I need, what memory I need to carve out, what methods I'm going to have to stand up and clean off afterwards that data and so on. So there's kind of a instantiation relationship where the model, it leads to the instantiation of data. You have data instances of the classes and properties in the model. Now, with a lot of owl ontologies, it's a similar kind of thing. You got the model that's an owl ontology, and then you have instantiations of that in RDF data. So the model is the model of that data. It's another kind of model of data. But what about when you have a concept ontology or explanatory ontology? It kind of goes the other way around. The things in the world already existed. What it's a model of, those are instances in the world that you then create some reflection of in your conceptualization of that world, in what classes exist, how they divide down taxonomically, what are the necessary and sufficient conditions for class membership, and so on, are all done by observing the world and then creating the model rather than creating a model and then creating data from that. So that difference in direction creates this kind of tension between the kinds of model there are. So we want to look at putting ontologies to work. We're going to hear from different people's experiences and issues and challenges in, that vision of that engineering kind of purity, if you like, of linking concepts to data. Does it really work? Are there hybrid ways of doing it, and so on? So we're going to hear from Corey Casanave of Model-Driven Solutions, Maxwell Gilmore of the Semantic Shed, and Alajan Tuzun of the University of Applied Sciences in Upper Austria. So that's my introduction. I think, are we happy what order to go in? Do Corey want to go first because you've got time constraints? We're going to try and cover all the introductions before you go anyway, but I think just on the safe side. So I'm going to stop sharing, hand over to Corey, who I believe has a slide or two.
Yeah.
I didn't make slides compulsory, but where they help, feel free to use them. You should now be able to share with a little green sharey button at the bottom there. Over here.
Sharing button.
Middle of the bottom, green.
Yeah, on the screen. Application windows. Yeah, there it goes.
There we go.
There we go. Thank you, Mike. And I think what I'm talking about fits very well into your introduction. And by the way, I made these slides very quickly after Mike invited me to talk. I started just kind of collect my thoughts and then ended up making slides. They're really boring, not a lot of cute pictures and such. But what I decided to focus is kind of around a concept of return on investment. Because when we're looking at a enterprise investment in semantics, obviously they're going to ask, well, what am I going to get out of this? And what they're going to get out of it, I think, does relate very closely to what Mike was talking about in terms of what you're modeling, the kind of model, and why you're modeling. So the proposition here is that there is a range of these ontologies and a range of what they represent. Well, let's say a range of models, as we have here, all the way from things that are, it's clearly data schema in any language to, the true definition of ontology is, as metaphysics and dealing with the nature of being. And I can tell you, if you go into an enterprise and you say those kind of words, they're just going to boot you out. Because that doesn't sound practical to them. And the disadvantage of the things way on the left is that we have information that's not integrated. It's very technical. It's hard to access. It's poorly defined. We know those issues. But there's also issues when we go very far on the, let's say the theoretical side, is that we end up with models that people don't understand. And if you're presenting this as something that helps them to understand things, they have to be able to understand it. And so what I'm looking for is kind of what I'm calling this sweet spot in the middle. that maximizes the ROI. So in doing that, you have to ask what would they get out of this? What are their drivers? And the drivers that I have seen, and I'm not saying these are the only drivers, certainly, but the drivers I have seen are focused on better understanding information and processes based on the business concepts. So they're frustrated with how technical their data is, and they want to look at things from a business perspective. They also want to connect that data. How does it connected? How does it feed together? You know, the old islands problem. They have tried to approach some of this with things like data dictionaries and tools like Calibra. And there are literally tens of thousands of entries in these things, of these data attributes. And so that solution has become its own problem. They want to understand the lineage of data, its authority, right? The flow of data through the enterprise and through systems. I'm dealing a lot with financial industry. Compliance and regulation are huge. And I can tell you, just in terms of buzz and attention, they want to know how anything's going to support AI and LLMs. And all of those, the things I just mentioned are things you can get from the models themselves, but then they also do want to take it down to the data, you know, to the knowledge graphs, essentially, and be able to poke at the knowledge graph and say, you know, show me this information that's integrated the way you're talking about. And that has to support LLMs. And I'd also add that most of the large clients I've worked with, they have a logical data model, probably pretty extensive. And they need to understand how this is better. And a lot of this comes from what we're modeling. And presenting kind of three levels here. And the nature of the world, right? The true definition of ontology is, you know, that's what when you look up the word ontology, this is what you find. This is what most of the academic work has been about. How do we really understand the world? But also, if you look at one of those models, it has to make choices. It has to pick a level. Otherwise, you know, if you're trying to, you know, model a desk or something, you have to get down to atoms and particles and things if you're really understanding realities. So even at that, you have to manage complexity from a point of view. And then I think there's what it calls shared concepts. Shared concepts are a little different than understanding the world. It's modeling how we understand the world, how we communicate about it. This is a bit fuzzy, a little fuzzier and more subjective. It's very connected with terminologies, but we know that terminologies are not sufficient because they're, you know, the terms can mean multiple things. So we want to normalize these concepts across, you know, the languages and enterprises. And there's kind of a bit of an art to this because, you know, you go too far the one way and you're just kind of modeling data, you go too far the other way and you get into the complexity of the world. I'm not exactly sure what to call this, an ontology, epistemology, something else. And then, of course, we have the data representations, essentially schemas, or even logical data models. But they've been doing this for a long time, and they're not solving the problem. They're still fighting with the issues. So my proposition is that there is this sweet spot in the middle. And the thing I put up there is actually a quote from a client a long time ago. You know, we're talking about why you'd want to do this. And his quote was, "It's about the data, stupid." But I think being about the data and being a data model are very different things. So I think there's this sweet spot. It is semi-formal. It is a model of concepts, but it's concepts that we can use, right? Their ROI is going to come from defining the meaning of data and also being able to pivot between data representations. So what does this thing look like? Like I said, it is a model of business concepts and terminologies. It has to be understandable in business terms with minimal noise. And one of the things that I find when I try and use some of the more formal methods is you have to introduce complexity almost to get around the language or to get around the representation. So if you have a concept that you should be able to represent simply, but you have overly complex or theoretical ways to express it, that reduces your ROI essentially. It has to be inclusive. We in a discussion with a colleague once, they were showing one of these models, and they say, "Oh, well, you have identifiers in there. That's not ontological." And I said, "Well, I don't care. I mean, the business, cares about social security numbers and things. So if they care about it at the business level, it belongs in there. It needs to be well defined, both with natural language and with formal definitions and relations. Including defining commonalities and differences, things that we do find in ontologies. Certainly relationships are crucial and really, I think, somewhat overlooked in terms of the relationships as things that define the entities and the entities that define the relationships. What this isn't is, again, it's not something specific to a process or a company. And one of the challenges in doing this is getting them not to introduce their specific context into the model, because that's what got them into the problem in the first place with their logical data models. They put too much, they model what they need for a process, not what something means, not even the basic business concept. And it's not a model of data structures, and it's not a model of terms, because terms, a concept can have multiple signs, multiple terms. Some of the, if you look at the business, and this is one of the things I've grappled with in terms of using particularly OWL. The world is not first order. The things that the let's say ontological community considers really hard are things that are just part of the world. It's temporal, it's modal, it's higher order, and it's contextual. And if we can't represent those things in an easy way, it's counterproductive. It's also, we are dealing with complexity. The business is not complex. And these models that we create to synthesize different groups, different organizations, different purposes are necessarily going to contain things that not everybody cares about. Nobody is can care about the same thing. Nobody's going to use the same terminology. One thing we found with the kind of the technologies and the languages is there's some use for inferencing, but it's not the main reason that they're doing things. There's a level of inferencing that is of great value, but some of the constraints that have been put in the languages that we use just to make inferencing or certain kinds of inferencing possible, again, are counterproductive. And most of the inferencing that's useful, at least in the enterprise, is closed world. So again, kind of from the customer, it's about the data. If you can't explain it, integrate it, federate it, it's not providing that ROI. So the challenges, the languages we have, and I would also include some of the upper ontologies, are not really tuned to this sweet spot in the middle. We're currently using Cameo Concept Modeler with Magic Draw. It's okay. It's a UML representation, but it's not ideal. Mapping that down to OWL introduces complexities. We have to deal with things like temporality and context in ways that are, you have to reify concepts. It just makes the model more complex, but there's really no alternative. And something I think is crucially important is there's no well-defined way to project this large model, this general purpose model, to viewpoints that are specific to stakeholders. If we can't take a generic model and say, this is the part that's interesting for you, this is how you can see it, this is maybe, the most important concepts and how they relate to others. Maybe there's hierarchical views. If we can't pull the thread on a model and have something that's simpler for view, we won't be able to make it resonate as business concepts. And in a similar way, there's no well-defined to map to data. There's very technical ways, but not a high-level way of saying how is this data representing these concepts, which is the essential. So kind of the summary of the thought is that there is a sweet spot. It focuses on these concepts. It's probably not what people call true ontology, but it's not a data model either. We really have to figure out a way to manage complexity, reduce noise, and recognize that as we come up with these neat concepts to model things or neat things in upper ontologies, that every time we introduce a concept that's going to be exposed to stakeholders, it has a cost. We have to train them, we have to explain it, we have to model it, we have to tool it. So the concepts in our modeling paradigm have to have an ROI. And while we can make some progress with what exists, we really need better ways to do concept modeling that's friendly and to provide stakeholders with these simplified viewpoints. So you may now throw the rocks and stones at me.
Thanks, Corey. There's a lot to digest there. That's a great set of challenges and alternative viewpoints. Who wants to go next for introductions? Max, you want to go next, or?
Is it maybe possible to ask him a question before he goes, because he will go in 30, so that we can have an answer maybe?
Yeah, people okay with that? I wanted to make sure we got introductions, but yeah, go ahead.
So that, in my opinion, your presentation was exactly what I'm dealing with. I'm also doing something similar. And I also saw that the all is, let's say, the constrained language, basically, which cannot represent the business things. That's why, for example, the founder of the Sumo is using this higher order logic to, let's say, do the same thing, basically. But the thing is, the higher order logic is really complex, so that we cannot use such thing in the business setting. So in your case, I couldn't understand how exactly you are dealing with this complexity and the capturing the business context, basically.
Well, for temporal things, the only tool that we have is to reify concepts, right? So that we can provide temporality, we can provide context, we can make statements about them. And what we have done from a tooling point of view is provide viewers for those models that essentially hide that reification, so that we can browse the concepts, browse the higher, these higher order relations. We can make statements about this, relations about statements about the relations, statements about the statements, because of the reification. So, and that's part of this kind of viewpoint perspective, that the presentation of the model has to be able to, well, in this case, since the underlying technology isn't that good at it, we've tried to do that in the presentation of the model. But when you're the modelers themselves still have to deal with it.
Alrighty, thank you. So, I see we got like hands up. This is almost like a regular speaker session, and our other two panelists haven't had a chance to introduce themselves yet. But I'm guessing because Corey has to go in 5 minutes, I guess the hands mean that we want to ask Corey specific questions rather than. I was hoping to interact more with these issues in the panel and bring in alternative points of view. But do we have a brief question specifically for Corey from John Sower and then from Paul Tyson and then from Ravi Sharma, or can any of those questions like wait to a more general panel discussion? John, you're up first. No, you're muted. I don't think people can unmute themselves unless they're co-hosts. So,
With their hand
indeed,
up
in
as a
industries.
co-host.
Okay. I wanted to make one point, and that is that there is a very important industry standard for representing everything, every possible version of logic, and enormous number of representations, and it's called Common Logic. That is an ISO standard, and it has been available for many years, and it's a superset of everything. And the point is that the Object Management Group has adopted that as its standard representation for everything, and it has excellent software development, and all you have to do is use it. Now, the point is that people complain that logic is very difficult. Yes, it is difficult if you have not taken a course in logic. On the other hand, there are excellent tools for mapping logic to and from natural languages such as English and others, and that gives you immense representation, very, very friendly, and it's far and away superior to OWL. OWL is just a tiny subset of common logic, but we can use ordinary, good old-fashioned English or other languages to map to and from common logic, which is also an OMG standard, and I very strongly recommend that.
I second that, John, and I wish I could use common logic. But you know the realities of the fashion industry of IT. That no one in that environment it's just not popular enough. Now, could we fix that? Yes. Is that a better basis than OWL? Absolutely. And I would certainly encourage anything we could do to make the the acceptance and also the tooling and support for that better. So yes.
Cool. Thank you, Corey. Paul Tyson, did you have a very quick question before Corey drops off? Or a more general point which you can bring to the more general discussion?
This is for Corey's presentation, which Corey, I agreed with most of this, and I think you're coming from a common experience that I've had in an enterprise. I'm talking specifically in an enterprise, not the web at large. Where I had a pretty significant disagreement is when you said that your concept model should not be business or process specific. What I learned decades ago was that businesses, enterprises exist because of their uniqueness. They're doing something different. They have a different view of the world that sets them apart from their competitors. And it's the modeler's job to discover that genius and preserve it and make it more efficient and make it serve the needs of the enterprise better. You don't do that by doing what everyone else is doing.
I would maybe clarify what I said is what you model can absolutely be controlled by your processes in your organization. But if you're modeling a concept, if you're modeling the concept of a dead instrument, you should not model the concept of a dead instrument as it pertains to a specific process, unless you very specifically are modeling, something specialized for that process. So what I encourage people not to do is introduce process specifics into generic concepts.
Okay, I get that, but yeah, what I've found is that there's a reason businesses do the things they do, and yeah, you can analyze whether it's good or bad, but the fact is, if they're in business and they're doing it that way, then they like it, and
yes,
so forth.
I mean, there's certainly absolutely fuzzy ground there. I do have to apologize. I do have to have this other call I have to run off to.
Corey,
I'd love to.
Thanks, Corey. And we'll
as an old colleague who has worked on many projects together, welcome to Ontology Summit. Thank you.
Thank you.
The second, I have two questions. One is relating to John Soa's cognitive memory versus your semantic concept model. Second is, can you think of outside the enterprise? And also, why are we not moving to information from data? How long will we be stuck only on
like I
data?
said, Ravi, I have to
So-
apologize. I do have to drop off. Very interesting questions. Maybe we can find a way to continue later.
Yeah, thank you, Corey, very much. Sorry you have to drop. And Ravi and Paul, we will pick up those threads of conversation in the panel more generally. So that's fantastic. It's a shame Corey isn't here to defend more of his thing as we go on, but I wanted this range of opinions. Exactly, that was the kind of range I wanted, because it's sort of distinct from the separation of concerns that I was describing and so on. So Max, do you want to go next, or in terms of introduction?
Well, the first thing is I have to apologize. I wasn't aware of the format, and I certainly wasn't expecting to put a formal presentation as Corey did.
No, nobody was.
My background is in the financial industry. Initially as a corporate treasurer, and subsequently in the banking industry, in the IT area of the banking industry, in terms of building models, data models to support the financial markets area. And I sort of started down this track with XML, and going back to 2000 with the JP Morgan FPML model, working in XML, and I guess graduated slowly to ontology through work with Michael as a subject matter expert when he was working with the EDM Council on what subsequently became the FIBO ontology. In saying that, I have a myriad of differences with the EDM Council, which led me to leave that group because I just found it incompatible with my way of thinking. But my objective has been to build a model that unifies the banking industry models. One of the things that I observed from within the banking industry was that they have a massive integration problem. And a lot of that problem arises from the fact that they have been buying applications, each of which has a subtly or brutally different model underpinning it. And because of the regulatory requirements, they need to bring an enormous amount of information to integrate it. And the cost of doing that is massive. I think the banking industry globally, you could easily say, spends billions, if not trillions, of dollars trying to integrate its data so that it can efficiently report to regulators and to coordinate its business and gather its information into coherent units. So my work, particularly with Mike, has been in coming up with an ontology that is well founded in academic principles that we can use to understand that financial data and help people integrate their data.
Whoops, I'm muted. Thank you. Yeah, it's a perfect introduction, and the same motivations and different end results in terms of what we did with FIBO, or what we tried to do with FIBO versus the direction it took, which kind of went from one end of Corey's scale to the other without parking in the middle. That's great. Thank you. Now, Alajan, would you like to introduce yourself? And yeah, over to you.
So that's my actually background is on engineering. Mostly I was doing some automation engineering, but after that I got to do the PhD. Basically now I am in research associate at the Austria, so that we are doing data-driven business model innovation for the incumbent manufacturers, where I am focusing on one manufacturer in this case, and then the topics which I am dealing is the optimizing the production line and also the analysis, like a strategic analysis of how the companies, for example, where the companies should invest on, or which sides or which ecosystems are suitable for their product or the services, or they have such new product and services where they should position themselves within that business ecosystem. Yeah, that is the thing what I'm doing. And as a PhD, I'm doing the computer science in University of Aristotle, where we are trying to, let's say, make this process better, where we are, when I'm doing this analysis, I am basically using the logic. As for example, the John Soa said, when we use the OWL, we came to the constraint, and now our let's say options were like using either the first order logic or going to another language. For example, the instead of the O to the L, as the Corey said, that for example they came up with the constraint, so that we are trying to get rid of this constraint and go to another languages. For example, as I said, it can be first order logic, or the other one was the O to real, which I was talking last week. So basically, I'm dealing with the business ecosystems, and I'm trying to help the companies to, let's say, analyze their environment.
Cool. Thank you, Alajan. So I think a common theme that I've noticed in all three of our introductions here, implicitly or explicitly, is this notion of what level of expressivity versus logic. And to unpack a little bit of what Max alluded to, when we started the financial industry business ontology, I was new to ontology, and I was creating what I would now call a conceptual data ontology. I was really looking for the concepts, but starting from the data, starting in that middle point, if you like. But as soon as we started talking to more conventional semantic technology stack people, it's as if, oh, the only thing you could possibly want to do is reason over the data. And because you absolutely must want to reason over the data, which no bank was asking for and still hasn't, to the best of my knowledge, because you must reason over the data, you must use this much less expressive thing. I was even shocked to discover that I couldn't even use the full set of XML data types, let alone XML extended data types like G, day, month, which you need if you're going to talk about bonds. What day of the month does it pay? So that kind of expressivity question, I'd love to know from each of the panelists, what you think about the expressivity versus restriction versus, what's it really for? I don't know who wants to go first, so I'll throw it over to either of you.
I can actually give one example which I encountered recently, not because of the ecosystems, but for another things. So the idea was when the managers are talking in some setting, for example, we get it now in MS Teams and so on, you can get the transcripts. And based on the transcripts, actually, you can extract useful information for the higher level manager so that the higher level manager will not be reading the whole text, but he can capture these concepts basically embedded within. And one of the methodologies in the research is using the qualitative analysis, so that you do the qualitative analysis and then you come up with the themes basically, which is not a formal way to categorize the things which is talked about, but coming up some basically like a higher order themes which actually let's say covers the whole talk. But the problem is when you create this hierarchy after this team by team, now the question is, how does this thing would be helpful for the companies? And now comes the formality so that you go from the informal to the formal. But the problem is because the text is really close to the natural language, it is really, really hard to do this type of formalization. So changing from informal to the formal through OWL2, for example. In my opinion, that is impossible through the case, so that you need to give up lots of information to do it. And I see, in the other hand, the higher order logic or the common logic, but then the problem is that it takes time to do it. So as Corey, in my opinion, really greatly said, that there is some sweet spot where it is really useful for the business to use it. And that is the one problem actually I came up with, so that I am trying to resolve this issue. But that's the problem where we can solve this two sides basically.
Thanks. Max?
Well, in terms of, I think the best way, from my viewpoint, of how I've come to use the ontology is to break down things and abstract things in ways that enable you to gain flexibility in your data models. An example might be in the banking industry. The way that banks have traditionally presented their data has been fragmented, in the sense that they've gone out and they've bought applications that enable them to do foreign exchange, and they've bought another application that enables them to do, say, their sophisticated lending. And then they've gone out and got applications that enable them to do commodities and futures markets and that. And what arose is a whole series of different paradigms that had to then be integrated, because clearly in a bank, all of that information that is being built up in banking lending areas and general banking transactions areas, financial markets, and financial engineering, all has to be pulled together by various risk divisions, like market risk division, by credit risk division, and also by accounting, because ultimately at the end of the day, the bank only keeps one set of accounts, and they need to bring all of that data together from a myriad of different applications. In reality, by breaking down the concepts that are involved there, it's possible to demonstrate that in fact you're dealing with a very small number of concepts, and you can use that to integrate things. Like, for instance, a foreign exchange transaction is just an exchange of two commodities, two currencies. A lending is just an exchange of two commitments to in the future. So, like, for instance, a loan is a commitment to pay money at the end of a given period and to pay money during the period in the nature of interest, which you can calculate by an interest formula. But at the end of the day, what you exchange is money now for money in the future. once you break things down like that and look at transactions, you can build a model that shows you that these transactions are just using different commodities. Like, for instance, a loan is an exchange of money now for money in the future. Foreign exchange is just an exchange of one money for another money. Buying gold is just exchanging a commodity gold for money. And you can then put those concepts together and build quite complex transactions from those fundamental building blocks. And it's been that by breaking it down that way, you can think about things, you can bring your process together and integrate your activities in the bank much more efficiently. It also gives you, pushing through that, it also gives you a path to integrate data, because in breaking down how each model represents the world and understanding how that fits with the more fundamental unified model, you can build integration pathways that are much more effective.
So in a way, what I think you might be saying is some of us have been asking the wrong question. It's not, should we be using L or RL or swirl or DL or DOL or whatever, but should we be abstracting more? It's not about the tools, but how we use them. That the key to both, I think, to getting to the meaning of things and to being able to integrate data that's structured around different concepts and stuff is this ability to think abstractly, to say, what sort of thing is this? What sort of thing is a securities exchange? Oh, it's a kind of marketplace. What sort of thing is a transaction, as you've described? What sort of thing is an address, is an index to a location, and so on? Is that what you're saying, that really we should be focusing on the thinking and the technique of abstraction rather than necessarily the language?
Yes, and in doing that, you can evaluate the tools that people are using. You can also develop a more generalized model, and you can work with the goal is to work to evolve those disparate models into a central model that actually does enable them to have an enterprise model. And you can start with an abstract model. You can translate into that, and ultimately you can evolve into a core model that makes the development, the integration of the industry much more effective. But you won't, you can't just change. You can't turn an ocean liner around on a pin. A bank is an ocean liner, so you need to develop a path for them to get it right, to get that common model.
That sounds like the real methodological challenge. Alochan, what are your thoughts on that?
So 3D abstraction, as he said, maybe like I can give you one example also in the ecosystem wise. For example, there is the concept of the bearing manufacturer, and there is the concept of anti-friction bearing manufacturer and hydrodynamic bearing manufacturer. So when you talk with an expert in the field, most of the time they are talking about the abstract terms, but if you want to have a deep dive information about, like, for example, if they are delivering to the anti-friction bearing manufacturer or the hydrodynamic one, could be crucial if you are standing on the point of any of the bearing manufacturer, because then it will be available information for you and not the abstract term. So, for example, as he said, that differentiating between the gold and the money, it is exactly the same case, because from the point of view of the bank, it is crucial, of course, but for the other partner or other node or other, let's say, entity, organization, maybe it's not so crucial. But in the point of view from the bank, I can understand the making such a distinctions. And this occurs, in my opinion, in all business cases, so that when you go more detail, actually, not only you are getting more precise analysis of the situation, but as well as the stakeholders and who contributes to your thing actually widens its perspective. So that when I, for example, introduce them that these different bearing manufacturers, actually even though they are gearing manufacturer, they were surprised or let's say like the idea of differentiating between them, because when you do, for example, a competitive analysis, and yeah, you can do it in the abstract way, but maybe doing it the lower way would result in a better solution for the company. And this semantics abstraction, I agree that it plays a great role.
There's an interesting thought in that like the abstraction seems to be the key to getting to common meaning. And your bearing example reminds me of an example at a bank I worked with a while ago, where they had this simple concept, they thought, or a simple set of words, which they assumed was therefore a concept, namely, what was it, active account or something. And actually there were 7 or 8 different meanings. So what happens is each silo has its very specific, and it's this abstraction that lets you get to what are the common things that then each of those are specifics of, which I think brings us a little bit to, I want to bring in a couple of Ravi's questions here, because we're looking at how we abstract up to the real concepts. So, for example, how relevant are formal economics concepts in a changing world, and if there are disruptive events, so obviously, like, we started with the financial ontology stuff in 2008. I was actually walking along Wall Street showing it to people the very day that the whole financial system imploded, and everybody had all the data, but it took them weeks to find what their exposures were because they hadn't been able to turn their data into meanings. Now we've got more shocks to the financial system, which I won't even try to describe. Max, this ability to abstract and define what the economic concepts are, is that something you feel has been critical?
Well, yes, I think you need to break it down. What I've been finding in my path from the data world into the ontology world is that when you do sit down and you think about these things, you risk initially being accused of angels dancing on the head of a pin. But as you break that down, and ontologically, you can do that very easily because you don't have to write programs to put concepts together and ideas together. But if those ideas are well constructed from good philosophical background, you come up with solid models of concepts, and in working them through, you can go 2 ways. You can take those models and build data models from them, or you can look at existing data models and you can work with people to analyze what is good and what is bad about those models. The old story, every model is wrong, some are useful. Well, if a model is working in a bank, it is useful, but you may be able to make it better by actually looking at the models and working out, what the problems are, what is causing impedance between models, and what aspects of a model are creating problems for your IT division in integrating, in developing new models, and stuff like that. It's a little. I hadn't prepared a presentation here, so I'm a bit scattered in the way I'm trying to explain it. But what you can do is you can break down what people are doing, and you can see the issues about what the problems are. And what I found in doing that is that working with the Unified Foundational Ontology, we've been able to break down our analysis and come up with well-grounded concepts that enable us to move forward and to break things down. A classic example in doing this is working with the UFOC model, which talks about commitments. Commitments is a concept that Mike and I came up with probably back in 2008, certainly not long after. And it's proved to be a very robust concept in analysing not only financial transactions, but also in the ERP world. I have a brother who has worked in that area for 25 years. And we've been able to break down those concepts and apply them very effectively in the ERP world. And you can see the commonality. They're the same concepts. They've just been restructured in different ways. Using UFOC, we've been able to break down the concept of a commitment and talk about a propositional content of a commitment being a goal and stuff like that, which we've been working on just recently. And I've been looking at taking the commitment as the primary element of financial or business models, and that's an undertaking by somebody to take an action of some description, and that taking that action may be conditional upon certain events occurring, and you can build a model that enables you to actually analyse that transaction and look at a commitment and all of the underlying conditions that are there, and basically break down your whole set of transactions into simple transactions that fit together.
Cool.
And what I found is that adhering to that formal model has given us some enormous insights into how things work, and that's been the beauty of the ontology and following, in this particular case, unified financial ontology, but we've also worked in other ones too. But when you look at them, they all work together in very similar ways, which is very encouraging because you're getting to fundamental ideas that are going to be stable.
Right. Cool. So I think one thing that Corey mentioned that maybe ties into that, we don't really have time to dive into, but I just wanted to put a pin in, is that by having this model that truly abstracts everything to the point where it represents a good conceptualization of reality as it's relevant to that entity, you really then do need these context-specific lenses to view it through for different stakeholders and so on. So look at the time, Ravi, we wove a couple of your questions into the thread. It sort of fitted very nicely at that point, and I wonder if you want to come back on any of your questions on the responses to those.
I will need 1 or 2 minutes, Mike, if you have.
Sure. If people are happy to go on, but to be on the top of the hour, we have a very rich amount of things to talk about. So I'm good with that.
Let me begin with asking 2 questions to both of you, Maxwell and Mike. 3 events happened: 2008 pandemic, and now the cataclysm in economic markets, which I don't want to make explicit, but I call it sovereign risks because it's affecting global markets. So let's give it a name, which is sovereign risk events like this one happening today or in this week. Things are happening, and Maxwell referred that there is classical electronic theory to be looked at. How well applicable is it in this kind of disruptive situation? Number 2, when are we going to go away from data and get to talk about semantic or information elements of meaning? It's related to what John Sowa told us, but not that direct.
So, Max, do you want to take that, and then maybe Alachan as well might have some views on either of those questions?
Well, the current financial crisis is just a pandemic of stupidity, but in terms of looking at it in ontology terms, what we're talking about is risk. When we see markets crashing, and we're talking about loss of value, etc., we need to remember that the only price of anything is the price you actually pay for something. The rest of our life, we're trying to estimate the price of the next transaction. So we come up with valuations that are based on looking at markets and working out things. And from a sovereign viewpoint, that risk is essentially a risk that the value that people put on things is wrong. And of course, in times like this, we have uncertainty. Uncertainty translates to volatility. And we can talk about the whole world as, in effect, an options model, which is pretty much the way a lot of economic models are actually working. So in sovereign risk terms, I mean, we've been through a number of crises in the financial world, which have been essentially people's misunderstanding of the way markets actually work. I possibly, Mike, you can jump in and help me here, because I need a little bit of time to try and get my head to get my mind around what I want to say.
Yeah, it's interesting. I think one of the things that struck us with the 2008 crisis was when we were able to model things like credit default swaps and synthetic credit default swaps and these tranched instruments and stuff, and we laid them out on the page in graphics. What we said was, hey, we need a way of showing something to the business we can explain in simple set theoretical terms without being mathematically precise about what a set is. To say, here's a box that represents a possible set of things, and these lines are things you can say about that. We put it all on the page, and then we look at the picture and like, well, this is horrible. I mean, that's what's happening in the financial world. Something's bound to go wrong. So just making knowledge explicit for business stakeholders was I think the first useful thing we got out of that. And this comes back, and I see Corey's back now, which is great. This comes back to, the benefit we got out of having a model that was purely about the business reality, not about the data, but for the data, versus Corey's, midpoint idea. So those are anyway, that's just my thoughts on that. Alachan, did you want to chip in, or Corey after that?
I have only a quick comment on that. In my opinion, here is the speed is the crucial term, so that how quickly you can explain these things to the business. So in this case, if you are agile and then you can do it really quickly, then it's all done. Otherwise, in my opinion, that's the biggest value for the business.
And this is the big gap in the tools. It comes back to something Corey said as well, and I've mentioned a few times since then, Corey, which is that once we have a model where we've abstracted adequately to really describe, fundamental building blocks like goals and commitments and entities and so on, and economic resources, then that's almost by definition incomprehensible to each of the business stakeholders individually and too general for any of their specific verticals. So we need some missing tool, I feel, that gives us the lens that says, from this context, what do I extract from that broad concept model in this context here or that context there? Corey, did you want to chip in on that?
Yeah, and that's absolutely, and it's part of, I guess, what I was expressing is viewpoints. But a relatively simple answer to that is being able to hide abstractions. So if you're looking at something relatively concrete, let's say a mortgage, yes, it and the relations from it are composed from things that it may have inherited, but they don't have to see that. One of the things that I think is really missing even in UML is the ability to have classes and show relationships to them that are inherited without showing the inherited things. I mean, the superclasses. And so some basic tooling like that. And that's not even really a viewpoint. That's just being able to show, inherited things. So some basic tooling like that can certainly help.
Yeah, the inheritance thing was a major barrier for anybody adopting or understanding FIBO because, if you apply the whole duct type ontological theory, you have subclasses each defined by their own defining characteristics, then you get down to something like a municipal mortgage bond, and it only has the one property that distinguishes it from a not municipal mortgage bond. Everything else, and then the business people look at it and go, well, you got a box here with only one property. You missed interest rate, you missed issuer, you missed this. And it's like, yeah, that's all inherited. And there was never any good tools to show all of that inheritance. So anyway, that's a tooling issue. Any other perspectives from the floor or questions? Max, yes, go ahead.
Just go through my thought together on the economic disruptions, etc. I think breaking down. I'm thinking back in terms of the global economic crisis, the 2008 crisis, not the one that idiocy just started. But what we had in that particular situation is an industry that was not really condensing out the fact that a mortgage loan exposes a bank to property. Because if you take a look at a mortgage loan, the loan is exactly the same no matter what. I mean, it's basically a promise to deliver money in the future relative to now. But it is associated with a piece of security that the bank has, where basically what you're saying is, in the event that I default on that loan, I will give you a piece of paper that effectively gives you a conditional purchase of my property, and of course, mortgage is wholly and solely a way of representing the title to property. So what wasn't realised effectively in financial markets by a lot of people, there were definitely people who did, was that what the banks were doing was accepting a massive portfolio of property. And their exposure to the property market was much, much greater than they realised, because they thought they could sell it. But of course, what you get in these massive markets is you get massive swings once you get out of equilibrium. And of course, people end up in markets they didn't realise they were in, and therein lay the crisis. But by properly breaking it down, people would have better understood what their real exposures were, and that is the beauty of actually taking that analysis, using an ontology to actually realize what you're doing in effect.
And what's interesting about that is that you're describing benefits of ontology here that have nothing whatsoever to do with data. It's all about actually providing a common understanding to the business of business concepts in order to understand risks and react to things in a fast-moving world and so on. So, and again, to sort of maybe pull it together a little bit, we've got the contrast between a separation of concerns where you have an ontology of pure conceptualizations. Some people say things in the world, but really the conceptualizations of things in the world. The challenge we had with FIBO was explaining to people this is not a data model, because they wanted another better data model, and that's not a data model. And then you have the ontology at the other end, that's the schema for data. You got Corey's idea of a midpoint versus my kind of engineering thing of having the separation of concerns that says, well, here's a concept model, and then here's your data model, and you can talk about the relationship between the data and the concepts. You can talk about test and validation and verification and so on.
Maybe I wasn't clear, but that's exactly what I was saying, that there was a concept model, this thing in the middle related to your data.
But as
Corey,
one ontology in the middle,
Corey,
Robbie had another point for Corey.
Corey, we are talking in this panel on reality to data, right? Now you brought in the concept of semantic concept data, right? Or concept and a sweet spot. I am now saying, when will we start thinking in the same terms as about information as we do for data, because it makes more sense, because information is semantically rich term compared to data. So when will that aggregation start happening, if not already, in ontologies?
Well,
Who
I
wants
think
to take that one?
you're modeling, we are actually modeling the information. But that's not the terminology business usually uses. They just say their data.
Interesting point, because anyway, John, you have a hand up, and then we'll probably have to bring this to a gentle landing, I think, because it's 10 past, people are starting to leave. But John Sower, you have a question.
One point that I would emphasize is that all of these representations, conceptualizations and formalizations are all, and even everything we say in ordinary language is an approximation. Nobody ever can state an absolutely final fundamental proposition. So all of our ontologies, the more general they are, the more approximate they are and the looser they are. The most precise ontologies are the narrow ones, such as an ontology for a bank, for example, and even banking systems. You can't have a universal banking system ontology because every bank has slightly different variations. And the same is true for every possible application. Things are constantly changing. Every time your operating system gets updated, your ontology is changing. So the point we have to emphasize is that the more general the ontology becomes, the more vague and approximate it becomes. And the most precise ontologies are the narrow ones. The narrower they are, the more precise and formal they can become.
Thank you, John.
Fantastic.
So, yeah, brilliant. And I think, Janet, you've been saying some interesting things in the chat, but not raising your hand. I wonder if I could impose on you to chip in with a word or two, and then we'll try and bring it to a gentle landing. And Janet Singer.
Yeah, I think so I was putting in the some of Tom Gruber's original discussion about his use of conceptualization in knowledge representation. And I think several of the points today have really emphasized the importance of thinking carefully about what a conceptualization is, because it all hinges on how appropriate the conceptualization is. I think the word ontology, so Tom Gruber originally said, an ontology is a specification of a conceptualization for a domain, and that was repeated as a mantra a number of times, and then people sort of, it became meaningless. It was said so many times, but and he also says that what exists in is what can be represented. It is there's the commitment to what is represented in when you have engineered an ontological artifact. That's different from the idea that an ontology is breaking apart the world at its joints. So people confounded those two perspectives, that you are creating an ontology in your representation with your conceptualization, with your commitment to your conceptualization, as opposed to, let's just look at the objects in the world and make a catalog of the objects in the world, and that is going to somehow solve our problems for us, which is a total misdirection. Anyway, so wonderful. People kept making the good points here. And I think this is really helpful for next year's 20-year anniversary, looking back over this whole effort. Really excited by that.
Thank you, Janet. Yeah, it brings back Corey's question earlier about, is what we're trying to or needing to produce really ontology, or is it phenomenology, or is it epistemology, or whatever? I think it may actually be phenomenology. We're just calling it ontology, but others may differ. It's how we create intentions with an S, because particularly with risk, like we've seen in finance, we don't want to talk about what exists. We want to talk about what better jolly well not exists, but we need to still talk about it. So we want very quick sort of one sentence kind of summary from each of our panelists, and then we'll wrap it up. Who wants to go first? Alishan? since you're on the screen.
Yeah, I guess today's like a really good fight, like I said by John Soa, was that even the language is a model of the real world in a sense, so that whatever we create, like engine with the engineering mind, basically will be the approximation of the reality. So that I guess the claim on that we are creating some concept, but this one exactly represents the reality is an overshoot, in my opinion, and from the practice also it is not useful for the managers as point of view, for example. That was the explanation by the last week. Thank you.
Cool. Thanks, Alajan. Max?
Well, I guess that, and taking to John Sower's point, the abstraction and generalization to me gives you a foundation to build the detail. So seeing the commonality in concepts is very helpful because it enables you to drill down more effectively and stops you from getting fuzzy concepts. So that's where I see the value of the more general ontologies. Ultimately, you will go to very precise ontologies, but if they're grounded in that foundation, they'll be much more robust. And if you build data models from those concepts, they'll be much more stable and you'll spend a lot less money maintaining them.
Fantastic. Thanks, Max. Corey? Quick summary.
Well, I wasn't here for most of the middle, so just say that I think this discussion is right on in terms of understanding how the effort that virtually everybody here has been involved in is going to evolve and become more mainstream and have more value. And I hope we continue with that pursuit.
Thank you, Corey. Thanks, Max. Thanks,
Alajan.
Alajan.
For a very good prepared presentation. Thank you, Corey.
So with that, I'll thank you all and hand you back to Ken, our gracious host.
Yeah, that was a very informative and really quite enthusiastic response to the topic. Now we're looking forward next week to Ravi. Can you tell us a little bit about what's coming up next week, Ravi?
Well, we have two essential threads. One, you have given us a task of talking about ontology and data. So I will be trying to concentrate on two large areas of where the large data have impacted the globe in a way. One is earth sciences and the other one or two more areas. The second part of my talk would relate to the recent Nobel Prizes using AI. And that is where whatever techniques that I can unearth from this maze of tools and techniques people are using to discover new science using AI. So this would be more or less a starter of the track 4. And then we have we have two speakers lined up. Both are listed on the, Elisa is one of them, and there is a new gentleman to our forum who is going to be talking about the same related subjects. I have to find one more speaker for the last part in May. Thank you. Is that good enough, Ken, or should I go more in detail?
That's great.
Thank you.
So I'm looking forward to seeing the next track, hearing the next track. I hope everyone can join us starting next week.
And welcome, please participate in track 4, which would help us culminate the summit towards mid-May or something like that.
Right.
Thank you, Ken.
Okay, so with that, we will adjourn. Thanks, everyone. Thanks to all the panelists, Mike, to everyone who participated.
Thank you, Ken.